Well, hello there. Welcome back. My name's Joe. People call me Mr. Mellon. Mellon. And so this video, we're going to go over the next paper. Paper number 4. The macroscopic dynamics and the matter-induced volumetric expansion. This is where the information really becomes a bit more intuitive than our modern understanding without it can make predictions. So things on a macroscopic scale end up moving in accordance with the laws of fluid dynamics once you take into account the amount of space it's actually displacing relative to the substrate. So we go through in section 40, section 39, the geometric shadow. We're all a 3-dimensional shadow of a 6-dimensional object moving in space, which we see as time. Section 40, the physics of the vacuum. It's a non-Newtonian, the Lant fluid, which I guess is shear thickening. I have a hard time pronouncing that one word, but it's shear thickening, meaning the faster that you move through it, the more it pushes back up to a certain point, by which then it will lock up and you can't push it anymore. So that varies based on the frequency of the viscosity of it all. So we go through in section 40, we go through all that. We go through the numerical validation of the scaling exponent, section 40.2, regime separation 40.3. That goes over where the lattice actually jams and why we see the vacuum cavitation the way it is. The empirical validation, we went over that zirconium silicon sulfide result in the quasi-particle. Then we go through the Reynolds bridge, scaling the geometry based on what we now know. And then we see the galactic velocity constant, which then matches the database that we already have for quite a few of these galaxies and how they move in conjunction with one another. So there's the consistency in massive spirals, why that is, with the way the fluid works, and these objects are pretty much just floating in space. Literally, they are floating. Okay, so we see that it's just in 4 dimensions on a substrate that we don't see. It ends up the next section 42, the origin of electromagnetism, the lattice elasticity. Okay, we are able to derive Maxwell's equations from this. And so ultimately, it's just the field itself, the Higgs lattice, which is responsible for gravity as well, in a way, moving. And so that's why those two terms are connected, just like the strong and the weak nuclear forces are connected on the 6-dimensional manifold board. So, and we go through the mathematical proof for that next. Section 42.4.2, fluid analog. Superfluid photons. In a superfluid helium-4, a photon, a sound quantum, travels without viscosity. It does not push the fluid aside. It is the vibration of the fluid itself. Similarly, the photon is the photon of the Higgs lattice, propagating as a mode of the substrate rather than an intruder within it. Meaning, whatever matter is making a volumetric expansion in space is wiggling. It's moving around. And it's also moving the lattice. We see that as electromagnetism. And the finite capacity of space itself is why we even see the the electromagnetism experiment that Einstein won his Nobel Prize for, the photoelectric effect. It's the only reason why we see that photoelectric effect in the first place. Einstein was extremely close to figuring all that out. If he would have known about the Higgs field, he would have had it. I guarantee it. But that clearly some work needed to be done by this equation, by this work not being finished back then. It gave us quantum mechanics and all the other parts that we needed, as well as string theory. So, which we needed that as well for the whole picture. Anyway, back to the paper. 42.43 has a physical analog. The field impedance. There is a cancellation mechanism that's mathematically isomorphic to the reactive power in electrical systems. In a system where the driving force and responses are 90 degrees out of phase, no real work is performed. The average power integral becomes zero when the angle reaches 90 degrees. The connection, similarly, the 90-degree offset of the photon's electric and magnetic components relative to the propagation vector ensures that the net vacuum displacement is zero. The photon is purely reactive wave of the Higgs field, transporting energy without displacing the medium because it's the medium itself. Section 43 is technological validation of the photonic lattice. It goes back through some experiments that were done already. Feel free to read through that and cross-reference it, check it, look through it. Section 44 explains why we see cosmological redshift and lensing. Again, if we're in a hydrodynamic fluid of space that's stretching out further than what we can see just with the matter alone, it's going to lens space itself. And so redshifting ultimately, as a photon's wiggling through the board itself, it's going to flatten out because the way that space is moving. As it's going through space, it's getting stretched further and further as the background blocks are also stretching and moving. So it explains in section 44 that, and it gives the math for it as well. Gravitational lensing as refraction. Wow, what a surprise. Refraction. We look at it and it refracts space, and they wonder, what is happening here? Why does space look like this? Like, come on, scientists, let's go. It's literally just displacing a medium that we're not taking into account that has properties. So this goes through that, and it also explains that QSM is not a variable speed of light theory, okay? The speed of light is constant. There's a good reason for that, okay? So, again, the properties of space matter. And we make a very clear distinction in 44.2.2 that this is not a variable speed of light theory. Now, obviously, if you're measuring light through a different medium or something, or through matter, obviously light slows down. That's not what we're talking about here, though. But the speed of light in a vacuum, it's set for a good reason. It shows why we see the light diffract in the way it does, using an equation that will calculate the deflection. Plug in the numbers. Once you have the information, feel free to plug it in. It'll work. I've been doing it for years now, technically. Section 45, galactic dynamics, lattice displacement modes. It explains in a way that those MIVEs, the halo expansions around galaxies, they also have an intrinsic angle of attack based on the lattice. So some of them have more of an angle of attack than others. That's why we see galaxies with dark matter and some without. We can derive the flat velocity. We can also show that why the halo is simply the displaced volume of the vacuum. We go through the numbers on that. And as far as galaxies without dark matter, again, it's an intrinsic property. If the system is existing below a critical threshold, It should not actually have a dark matter halo. It doesn't have enough objective geometry behind it to modify space. Its angle of attack is too shallow. It probably coalesced in a different way. So, but yeah, we go through the evidence for that in section 46. There are multiple examples, by the way. Section 47 is resolving anomalies for the S8 and for Cloud 9 for a specific galaxy reference and observations that we see. Section 48, dark energy. Intrinsic kinetic momentum. When you get down to a small enough level, these six-dimensional manifolds are spinning with no actual resistance, just from the Big Bang itself. The stuff started moving. That energy is still there and is what dictates the moment-by-moment matrix, the size of each of those moments. So we go through in section 48 and kind of lay out what that is and why it can only be so much too. Expansion can only go so fast based on the properties of the Higgs, and it can, once it gets down to a certain level, it's timeless. It's just moment by moment. There's nothing stopping it. It's going through the laminar section of space, resistance free. The dual nature of the vacuum cell, it has duality forces. It has a propulsive base factor and a resistive limit. Again, the cutoff and the baseline cutoff and the maximum capacity. The additive inverse is the vacuum impedance. Section 48.2, we resolve the Hubble tension with it. And we kind of show that that's really their variation in their measurements are what they should see, given what's in space that they're looking at. And that takes us to our conclusion. The anomalies of the dark sector are not evidence of missing particles, but signatures of a hydrodynamic vacuum governed by the duality of impulse and impedance. It shows that there's more to space than what we can actually see, and that the objective geometry of the standard model and its parts and the angles that it hits space at matters, and we can explain it now using this math. So, and I know it's a lot, and again, this information here, I'm just running down through the paper from start to finish in a surmised format, not very formal, okay? That's kind of important. These are complex ideas, but not really. It's just different, and it comes at this problem uniquely. And I'm pretty sure that once, more people see it for what it is, they can kind of figure out the best ways to utilize this information productively. So, but anyhow, this was a shorter video. These last two papers were not as long as the first couple. The first couple really did a lot of the heavy lifting. But once again, this is 5 years of labor getting this situated. And if it wasn't for me having an AI advanced calculator that could do the calculus and the trigonometry and stuff, I would have been stuck doing the simple algebra. So, yeah. The timing is right. AI on, right? That's the middle section in Matthew 12:32. Ho AI on melon. So, yeah, thank you for having an advanced calculator. Wonderful. Now we can get to the meat and potatoes of all the information and take it from there. So, but once again, thank you for watching. We've got one more video covering the base paper for this session for our Easter release. And I know these are just simple videos. They're not going to have a lot of bells and whistles to them. but that's okay. We can get on to other topics later. So anyhow, thank you again for watching, and may peace be with you, and ho, Aeon Melon. Take care.